let's get started. So any questions on how to properly initialize neural networks?
I think I understand the concept of creating the ideal distribution to normalize the variance part. I tried to complete the proof on my own for this entire column in the middle, and I was kind of stuck on the step where the expectation of XL squared equals to 1/2 of the variance of the previous layer. This line, yes.
So you mean here?
Exactly.
So let's take a look at YL or YL minus 1. And let's say this is your activation function. We know that XL is equal to the ReLU of YL minus 1. It means that half of the time, your values are going to be 0. The other half, they're going to have the same value as you would expect. Okay, so half of the time it is absent, half of the time it is present. But what you can do is write down that expectation in terms of integral. So it's going to be an integral of your x squared times your distribution. Now x is a function of YL. It means that that integral, you can write it in terms of your XL squared, and your probabilities, your probability distribution could be with respect to the probability distribution of YL. And then you can basically half of the time, your distribution is going to be zeroed out because of the ReLU. So the corresponding value doesn't exist, it's just 0. And your integral is over half of your interval. So does that make sense?
Yeah, I think so. It did not came to me to think it as an integral in my first try. I think I'll try it again after the class. Okay, so it's from -infinity to infinity.
Yes. So these are not high dimensional because you are doing everything element wise. These are just one dimensional distributions and one dimensional random variables. So yeah, and it's because ReLU is killing your distribution half of the time. Not the distribution, is killing the actual values when you write down your expected value.
Okay, thank you. I'll give it a try. And if I still don't get it, I'll send you an email.
Yeah, and we can work on it together.
Thank you.
But what I want you to take home is not the details. Maybe the details are important. If you change your activation function to something else, then you need to start recalculating these expected values. What I want you to take home is the big idea that you are multiplying a lot of numbers together. And whenever you multiply a lot of numbers together, things could explode or vanish. The idea is to look at the variance of your variables and then try to control the variance so that your values don't vary too much from one layer to the next one. And in the end, the formula you're going to use is this. And what is already implemented for you, for instance, in PyTorch or TensorFlow, when you say initialize, or as soon as you define a variable, this is how they initialize it behind the scenes.
Is there a name attached to this initialization schema?
Yes, it is called Kaiming's initialization. So the first author. So it's going to be Kaiming's initialization. There is also Xavier's initialization, which is a little bit older. That one is for when you have tanh or sigmoid as your activation. In those cases, this is true. I mean, the expected value of your XL is just 0 because tanh can take positive and negative values. So the initialization there is slightly simpler, but it's again the same idea. You look at the variance of your layers. Okay, any other questions?
Thank you.
No, sure. Any other questions before I move on? Okay, perfect.